Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.2, Problem 6. This is Section 11.2, Problem number 6. It says consider the function f of x equals 3x squared minus 2x plus 5 when you use an input that's less than 1. The output is 2x squared minus 1 when you use an input that actually is 1. And the output is 6x when you use input values that are greater than 1. So it's defined in 3 branches. Again, it makes it look very complicated, but most of the time you're just dealing with one branch at a time. You have to decide which one you want depending on what you're putting in for x. Like if you put in an 8, it's just you're only dealing with this bottom branch. So now part A, is this function continuous when x equals 1? So we have to answer the 3 questions that we always answer when we determine if a function is continuous at some point. And then there's a part B, is the function continuous when x is 3? So first, when x is 1, is the function continuous when x is 1? Can I actually use a 1 as an input? Can I put in a 1 and get an answer? And I can. So the function says, the middle branch says, when my input is 1 exactly, the output is 2 times x squared minus 1. So 2 times 1 squared. So I'm going to have a 2, and I'm going to subtract 1. So does f of 1 exist? Yes. F of 1 equals 1. When I put in a 1 as an input, I get out a 1 as an output, based on the middle branch of the function. Now, question 2. Does the limit of this function as the input approaches 1 exist? Now, to determine that, I'm going to have to use the top branch and bottom branch of the function. Again, as my input approaches 1, I want to test for input values that are getting really close to 1 that are slightly less, like 0.9999. And I also want to see what's happening when I use input values slightly bigger than 1, like 1.00001. So as I use inputs that are just a tiny bit less than 1, the output I'm going to get is getting very close to 3 times 1 squared minus 2 times 1 plus 5. So 3 times 1 squared, that's going to be 3. 2 times 1 is going to be 2. So I have 3 minus 2. That's 1. And then I'm going to add 5 more. 1 plus 5 more. I'm getting very close to 6. As I'm putting in input values very close to 1, the output's getting very close to 6. Input values that are slightly less than 1. Now, as I put in input values that are slightly bigger than 1, 1.0001, I would evaluate that part of the limit with the bottom branch of this function. The output is also getting very close to 6. 6 times x gets close to 6 times 1, which is 6. So they're going to the same value. So the limit does exist. The limit of this function as the input approaches 1 is equal to 6. Now the third question, does f of 1 equal the limit of f as x approaches 1? And the answer is no. When I put in a 1, I get a 1 as an output, but as I take the limit as the input approaches 1, I get a 6. 1 is not equal to 6. So my conclusion for part A is this function is not continuous at x equals 1. Now, part B, is f of x continuous when x equals 3? Well, when x equals 3, I only really need to worry about the bottom branch. The bottom branch says the output is 6 times x when my input is bigger than 1, and 3 is bigger than 1. I can get rid of the 6 from part A. Let's get rid of that. So, can I put in a 3 and find that answer? Yes, I can. I use the bottom branch because my input's larger than 1. 6x becomes 6 times 3, which is 18. So f of 3 equals 18. Can I take the limit of f as the input approaches 3? And the answer is yes, that's also going to be 18. It can all happen in the bottom branch. So as I use input values slightly less than 3, say 2.9999, I can check that with the bottom branch, and my output's going to get very close to 6 times 3, which is 18. Also, when I use input values slightly larger than 3, 3.0001, I can still use the bottom branch because my input's bigger than 1. And the output's going to get very close to 6 times 3, which is also 18. So the value of the limit as the input approaches 1 is 18. The third question, is f of 3 equal to the limit of f as x approaches 3? Yes, they're both the same. They're both 18. So my conclusion for part B is it is continuous when x is 3. So again, for part A, this function was not continuous when x equals 1, but for part B, it is continuous when x equals 3.